I scored a perfect 36 on the ACT, and over the last 7 years, my team has helped thousands of students get to their dream scores on this test as well. And today, I'll be going over the ACT math strategy that I've used repeatedly with every single student who's improved their score by over 5 points on this test. It's the same strategy that Ava used to bring her score from a 22 all the way up to a 30, and that Mia used to bring her score from a 25 all the way up to a 33. And I'm going to explain why fixing just this one thing has the highest return for your ACT math score. More than memorizing more content, more than drilling more practice questions, and more than pretty much anything else that you could be doing. So if you or your child are stuck on the ACT math section right now and not sure why your score isn't going up, this will help clear things up for you. So let's go ahead and get into it. So right here, we have 5 different types of questions that students in our coaching program very recently had questions on. Question type number 1. So what I did here is I came up with a couple questions that students were asking recently that were super common. And then we also have other examples of how the ACT twists kind of the same concept into a couple of other different examples. So let's look at number 5 here. So how many minutes would it take a ship to travel 100 miles at a constant speed of 40 miles per hour? So on questions like this, we teach all of our students that we need to immediately recognize this as a distance, rate, and time question. So that means we're all automatically just going to go ahead and write out the formula distance equals rate times time. In this case, we know that the distance is asking for a ship to travel 100 miles. So that's just we're going to plug this right into the distance formula. So distance is 100 equals the rate. Anything that we have per, like anytime we see this word PER, per, like miles per hour, feet per second, anything like that, that's going to be our rate. And so we just turn we turn the rate into 40, and then they're asking for the number of minutes. So then we just know that we go 40 times t because we're looking for t here. And now when we're isolating the t, we just divide both sides by 40, and you can either do that on your calculator or in your head, but we get 2.5 equals t. Now, the one trick that the ACT will always try and throw in here is the actual units themselves. If we were measuring our miles or our distance in miles right here, and we were measuring our speed, our rate in miles per hour, then this t right here will give us hours. So we have to know that, the answer is not going to be 2.5, but that's going to be the number of hours that it took to travel. So we need to just convert this into minutes. So if we have 2.5 hours, we multiply that by 60. Again, we can punch that into our calculator or do that in our head. And either way, we get 150 for our final answer right there. So the big takeaway here is that we just want to immediately plug in this distance equals rate times time formula. And no matter how the ACT asks this question, whether it's something like number 60 down here, number 20 down here, we're gonna have a very, very similar way of solving this. We're gonna immediately jump to distance equals rate times time. And the big thing is all of our students are gonna be very cautious of the units that we're using as well. We're not just gonna default to assuming that 2.5 is the answer, but we're gonna pay attention to what the actual units are as well. So whether this is a super simple question like number 5, or a more difficult one like one of these down here, we're going to take the exact same approach. And if you can do that, then you can apply this one lesson to a whole bunch of types of questions. Obviously, I was able to find these questions pretty easily as this type of question shows up all of the time. So if you can make it second nature to solve these questions very efficiently, like we just did here, we can save time on the ACT and we can become more accurate. It's like a double win right there. It's a win-win. So let's go ahead and dive into number 7 right here. So when we look at number 7, right off the bat, we see that it's a longer word problem. The way that I like to think about these questions is that there's the first part of the question, which is like all of the information. We know they're going to give us a bunch of numbers and stuff like that. I kind of sometimes like to just start out with what the question's actually asking, which is the second part of the question. So how many gallons of paint were left when they completed their first day of painting? So we know we're gonna have to go back into the question and find all of these details anyways. So we might as well just start using our brain power on the actual question itself rather than all of the information and like all the little numbers that we're gonna have to go back and look at again. So we know we're going to be looking at a day of painting and we're looking at how many gallons of paint were left. Now let's go find the details. So these two people started with 4 gallons of paint. That's like they're starting. On the first day, one person, this guy used half a gallon and Ming used 1.25 gallons of paint. And now in this case, when we're looking for how much was left, we know we're just taking the starting amount of 4 and we're subtracting out the other 1/2, and then 1 1/4. Our final answer is going to look something like this. Now, again, this may seem like a pretty basic question, but it shows up all the time. Like, we have multiple examples of this question being asked. So we need to have a very good approach to answering this question efficiently, not only so that we get it correct, but so that we save a lot of time for other questions later on the math section as well. Now, what I recommend in order to actually solve this is you have to kind of know what your level of math is. If you can do this in your head and you can do these fractions and mixed numbers very quickly in your head, that's awesome. So I can just look at this and I know that my math skills are good enough to where I can do this in my head. 1/2 and 1 1/4 combined together to be 1 3/4, and then 4 minus 1 3/4 is going to give me 2 1/4. So I can do that in my head, but if you can't do that in your head, then just go ahead and punch this into your calculator as well. If you have like familiarity with your calculator knowledge and how to use it, you can convert this mixed number into either an improper fraction or just, a number with a decimal, or you can convert it into a regular fraction. Of course, you want to be familiar enough with your calculator to be able to do that. And you could just type in, 4 minus 0.5 minus 1.25, or, however works best for you. And you'll probably get 2.25 as your answer on there. And then again, you just want to be familiar enough with your calculator to where you can convert that back into a mixed number. And that's where, again, you have to know what your strengths and your weaknesses are. We have some students who we encourage them to use the calculator on questions like this. And we have some students who we encourage to do the math in their head and get to the answer a little bit quicker that way. Now, again, the key takeaway here is that we need to solve these questions efficiently, and we need to be able to transfer this type of knowledge to other questions that show up as well. So a question like number 20, when we may have to calculate the square footage, or even a question like number 13, where it's a very similar type of question, and we just need to do some sort of subtraction or addition in order to find out what's going on. The key, in my opinion, is to start with the actual question itself, so you don't make some sort of silly mistake, and so that you can go ahead and just jump right into solving this one and save a lot of time for the other questions on the math section. Now, that's where a lot of students go wrong, is they'll spend a minute on a question like this when they should be spending 15 or 20 seconds and saving that time for questions that are more difficult or more complicated later on in the test. So let me go ahead and move this out of the way, and let's dive in to question type number 3. So in right triangle ABC shown below, AB is 9 units and BC is 12 units. What is the sine of A? So we know this is just kind of a straightforward SOHCAHTOA question. They give us the lengths of the triangle 9 and 12, and now we just need to find sine of angle A. So anytime we're looking for sine, cosine, or tangent, we're always looking for that with respect to a given angle. So it's never going to be like side length A inside of a sine or cosine or tangent. So that's one thing we always want to be aware of. And if you are already great at SOHCAHTOA questions, then you need to be able to take your skills from a question like this and also apply them to tougher questions like these down below. But we need to master the basics first. So let's look at question number 29. It's asking for the sine. So we know SOHCAHTOA, S-O-H. The trick is sine is equal to, so sine of A is equal to the opposite side divided by the hypotenuse. So now when we're looking at this, the trick I always use is just draw an arrow opposite from that angle of A that we're looking at for sine of A, and that's the opposite. So now we have 12, so 12 divided by the hypotenuse. Now we don't have the hypotenuse right here, but we can figure out the hypotenuse in two different ways. We could either use the Pythagorean theorem and add 9 squared plus 12 squared and then take the square root of that, or we could actually simplify this down. We see that this is actually just a multiple of a 3, 4, 5 triangle. So basically just a 3, 4, 5 triangle multiplied by 3. Like, we could simplify the 9 down to 3 and the 12 down to 4 if we divide both sides by 3. And then that would make this a 3, 4, 5 triangle. And then this would be 15. Now, if that was too much for you, then you could also just do 9 squared plus 12 squared equals this third side squared. You could call that C squared. And then if you do that, you punch that in your calculator. I don't need to do that for you. And then you take the square root and you would get 15 for that third side as well. Now, of course, if you do know, which all of our students do know, their right triangle. Now, of course, if you do know your common right triangles that show up on the ACT, you know that this 3, 4, 5 triangle shows up a decent bit. That's something we train all of our students on. So that's why I wanted to just skip to this kind of 3, 4, 5 and then multiply it so we can get this sine A equals 12 over 15. And what we do here, we divide this again by 3, or you could just use the 4 and the 5 from our simplified version, and you get 4 over 5 there. And then we know that this is answer choice C. Now, this type of question shows up literally all the time on the ACT. So this is one that we really want to have down as much as we possibly can and just have this type of question in our back pocket. So, we see it all the time. There's like question number 32 here, question number 50 on a different test. These are all the types of questions that we would want to have this SOHCAHTOA formula down and really know the ins and outs of it. So not just knowing how to do it when they're asking for this third side over here, but how can we go in the reverse direction as well, where the answer choices are going to end up giving us some sort of sign as well. So of course, not just taking this from one type of question, but being able to apply this knowledge into a bunch of other types of questions. This is something you would really want to drill. And if you can work on a lot of these types of questions in a row, then you can really ingrain this knowledge in your head again and again. So that's question type number 3. Here comes question type number 4. This is another really good one. We're gonna get a little bit trickier with some of the terminology here. So we see question number 38 right here. We have, a big old graph that I think a lot of times these graphs and these tables can be confusing and overwhelming. And so I see a lot of students mess up on questions like this. Now, I'll kind of do the same thing again, where I start with the actual question down here, and then I'll go back and look at all the information. Again, this is all just information. I'll ignore it at first because I can save time, and then just go back and look for the information that I actually need. Because a lot of this stuff will be unnecessary and it's just there to confuse you. So that's one of the big things that we teach all of our students is just cut away all of the ACT's tricks and their traps that they're setting for you, the extra information. Just start with the question. So what is the median daily distance in miles that Jonathan rode his bike for the 18 days? So we're looking for median distance here, and median, we always say, is the middle. So median equals the middle number. And we have a couple different ways that we're going to want to find this. Now, in this case, we do have a chart here. And again, we can kind of just look at this now. Now we just don't even really need to look at any of this. We can just basically look straight at the table, and we've already saved ourselves from wasting our time looking at a bunch of information. We just see that we have distance in miles right here on the left, and we have the number of days on the right. So this is a chart that shows up a decent amount now on the ACT, especially with the new enhanced test. They're rolling out charts like this a lot more frequently. And this is what's called it's a variant of a frequency table. So this is not something that students are used to seeing in high school, but it's something that we definitely have to know if we're going to be able to solve these questions very quickly and very accurately on the ACT here. So the number of days, this is the frequency. This is how often this guy is riding his bike for this distance in terms of the number of miles. So for example, he rode 7 miles, 3 separate days, and he had shorter days where he only rode 1 mile on his bike, and he only had 2 of those days. So that's kind of how we should think about these frequency tables. This is how often he does something, and this is the actual value. Like this is like how far he went. In some cases, it may be how many points a team scored or something along those lines. Now, when we're looking for the median, that's the middle number. So normally, I think people are used to having like maybe a bar graph where they're finding the median and they can cross off numbers on the left and the right in order to find the median. That's what like a normal median question would look like, but we also have to be able to do this in a frequency table like this. So when we're finding the middle number like of miles that he rode, we can cross off the highest and lowest. And we say, he had 3 days where he rode 7 miles. Well, if we get rid of those top 3 days, that would also cancel out the bottom 2 days, but then it would also cross off like one of these next bottom days as well. I guess the other way you could think about this is, he had, if we could list out all of these numbers in terms of like the number of days that they rode. So like we had 2 days where he rode 1 mile, we had 4 days where he rode 3 miles, and so on and so forth. Obviously, I don't want my students actually writing out all of these because then it's gonna take us way too long. But that's kind of how we should think about this. And so, you know, really, if we had 3 sevens up here, then we crossed off those 3 sevens. That canceled out 2 of the 1s, and then we also canceled out 1 of the 3s. So that's like the visual reminder of what these frequency tables look like. Now, we just want to keep marching our way down, and so we cross off, I guess we can cross off the bottom, we cross off the 3, and that gets rid of 3 of these, you know, 5 miles as well. And now we're actually left in a situation where we have the same number in the middle. So we have 3 4-mile days and we have 3 5-mile days. So now we know that both of these are gonna cancel each other out, and we're gonna end up right in the middle of this 4 and this 5, which just means that we take the average of 4 and 5 together for the median, and we go with answer choice J. We meet right in the middle of all of these. So that's how we can look at these frequency tables. There are some other similar examples that we would have as well, which are similar types of questions. You know, we have mean and median questions like this that we would also want to know how to do, not just when they give us a frequency table, but, you know, whether they give us a list of numbers like this or just a word problem like this. And then same thing here when we have a table like this, where this is a frequency table, the number of days, and then the number of defective computers. So a lot of good lessons that we can take from this one type of question and apply it, you know, to other types of questions as well. Like we shouldn't just ever learn one type of question and then forget about it. We want to understand, you know, hey, I just spent some time learning this type of question. How does this also apply to other types of questions? And that's exactly what we do in our coaching programs. We provide all of these questions grouped together so that students can go in and understand, okay, hey, I just solved number 38, but how can I take that lesson and kind of spread that out towards multiple types of questions? Finally, we have our last question type number 5. This one is a good one that shows up pretty frequently, and a lot of students will mess up questions like this, and we have a pretty simple way that we can solve these questions very, very quickly and very efficiently. So I'll go ahead and start off with the question again. How many seconds elapse until the 2 signs next flash at the same time? So this one might not make quite as much sense until we read all the details. But one welcome sign flashes every 8 seconds and another welcome sign flashes every 12 seconds. At a certain instant, the 2 signs flash at the same time. So we have, this is what I would call a repeating patterns type of question. We have one thing, this first sign, let's say like sign number 1. So sign 1 right here, S1, and we have S2. And then this one flashes every 8 seconds. So this one goes like 8, 16, 24, and so on and so forth. And then S2 flashes every 12 seconds. Again, this type of question shows up a decent bit of time. So if you can recognize this right off the bat, you should automatically kind of plug in this type of thinking on a question like this. So we're really just looking for how long until the 2 signs flash at the exact same time. Let's say they both started at 0, and that's when they flashed at the same time. Then we can just basically go and count all this out until they next flash at the same time, which in this case didn't really take long at all. They both flashed at 24 seconds. So what we're doing here is just, there are a couple of ways you can go about this type of question. You can just write out the pattern 8, 16, 24, 0, 12, 24 until you get to the same number, which we did right here. Or you can recognize this as a least common multiple type of question. Our students all have, calculators where they can plug in least common multiple things, or you can, if you understand least common multiple at a very intuitive level, you can find 8 times 3 would be 24 and 12 times 2 would be 24, and you could just know that as well. So multiple different ways to approach this problem. The most foolproof way is to write it out like this, and in most cases we know that the ACT is not going to have these patterns go on for such a long time that it would take too long to actually write all this stuff out. A lot of times it's very, very easy. We just saw, I did this in like 10 seconds. So it's not like we wasted a lot of time by just writing all these things out. So I typically recommend that students should do that as well. We have a tougher variants of this question as well that a lot of times mess people up. But we can take this exact same thinking and apply it to any type of repeating cycles or repeating pattern type of question and solve these all very, very quickly and very easily. So that's the big takeaway, is just taking a lesson like this and applying it to other types of questions as well, and working on these questions in conjunction with one another rather than just, practicing question number 16 and then never seeing another repeating pattern question for, another 2 days when you maybe, see the next one on your next practice test. So now, quick recap. We've basically gone over 5 different types of questions that show up super frequently on the ACT, and we've gone over how to solve them and also how to take those lessons and apply them to other very similar types of questions so that you can get more overall accuracy and save more time, so you can get even harder, more difficult questions correct. So it's overall a win-win. Now, if you have any other topics that are tripping up you or your child on the ACT math section or any of the other sections, drop those in the comment section down below, and I can make another video covering what those are and how we teach students in our program how to solve those types of questions. Or if you want to just have 24/7 access to asking questions like these whenever you want, that's just one small benefit of joining our ACT coaching program. Check out the link in the description if you want to learn more about that. Otherwise, I'll go ahead and see you in the next video.